Internet of Things. Making your business activities actionable using Apache Software Foundation projects. Apache Ecosystem, Data Acquisition and UX. Let's say you would like to assess, through a dashboard, your business assets, such as your airplane fleet or your machines. You would need some sensors or microcontrollers, such as an Arduino. Pre-processing of the gathered data can be done on some affordable all-in-one microcomputers, for example, a Raspberry Pi. The next step is to store this information in a persistent manner, to make this actionable. Backend databases are necessary to store the sensor's transactions. The variety of databases, both traditional RDBMS and NoSQL can do that, DB for small datasets, CouchDB for mobile and replicated databases, Accumulo for high-throughput access and Cassandra for large distributed datasets. An HTTP server is necessary to handle users' requests and manage the user interactions. Apache's HTTP server is well suited for this task. The next question is how to get the data acquisition to communicate smartly with the end user. A web application server such as Tomcat or Tomy becomes handy to manage your dedicated applications. It is also a backend for the Apache HTTP server. Camel allows you to gather your business data from different sources, for instance, from Twitter, for sentiment analysis. Giraffe is used to create iterative graphs of relationships. This is relevant to identify impact analysis. For instance, when identifying the supplier and the items this supplier provides your business. Solar can be used to perform enterprise content search. Lucene indexes and classifies business documents. Apache Marmota is a stand-alone linked data platform that allows you to build custom applications that relates significant business objects, for example to report your business state. Sesame is an open-source resource description framework that Marmota uses. While not an Apache project, it ties into the narrative by being the foundation to Marmota. MySQL, PostgreSQL or H2 are the only supported database backends for Sesame, used in conjunction with Marmota. Although none of these databases are Apache projects, they tie into Marmota. A message broker, such as Apache's Kafka, is used to stream the data acquisition. All the messaging are interpreted to ensure urgent messages are addressed in priority, for instance, using Apache Storm. Hadoop manages large datasets from sensors or business operations that can be sliced and diced to perform reports or help identify actionable items that need resolution. However, it is not the best choice for cluster computing. Spark is the cluster computing solution you should look for when concerned with response time. It operates on top of Hadoop and accesses Cassandra, HDFS, HBase. Pig is a preprocessor for your big data. It produces instructions for MapReduce programs to improve processing and reduce the operation time necessary. HBase allows to read and write data on the Hadoop and HDFS data, randomly and in real time. It is distinct from Hive in the sense that you can use RESTful web services. Hive is a data warehouse that front-ends the Hadoop data platform. It enables you to query the data in a SQL-like syntax. Scoop is your tool to integrate legacy databases into Hadoop, HBase or Hive. Zookeeper is an Apache administration tool for big data, to manage synchronization, configurations and group services on your data platform. Avro formats contents, also known as serialization, for consumption by other applications. Knox Gateway ensures your private data stays private. It ensures RESTful access to Hadoop clusters are allowed for correctly authenticated sources. Chuqu is an administration tool that displays, monitors and analyses MapReduce results to make the best use of the gathered data. Falcon manages data transport, process choreography, data discovery on Hadoop clusters. Apache Flume is a service that collects, aggregates and moves large amount of data such as logs. It can also be used to load data into your Hadoop data platform. We'll also see how to integrate your legacy applications. Let's start at the bottom left of this page. The first step is to capture and digitize the data your products and processes generate. The next step involves pre-processing through a microcomputer, such as a Raspberry Pi or BeagleBone. The microcomputer is used to generate messages Kafka and Avro can interpret. Kafka feeds Storm and Zookeeper. Storm can store data in a variety of databases. At that point, we have not yet stored anything in Hadoop, but we have persistent data we can investigate. Accumulo can be queried by Hive, and can feed Hadoop as well. Chirp, Hive and Spark use Cassandra as a backend. Accumulo and Cassandra can be used to feed Pig, for analytics and jobs processing. Pig prepares MapReduce instructions for Hadoop. Remember, Scoop can aggregate data from different databases, as well as flat files. This relationship is invoked here to capture the intermediate activity stored on dedicated databases that have been selected to match the working conditions. Scoop can also be used to push data into Hadoop, through Hive or HBase as well. HBase can also be used as a foundation for Spark. MapReduce results are stored back into Hadoop. Hadoop data is then available to a variety of data stores, and can be reprocessed through Spark. Spark high-speed cluster computing can be fed back to your data platform, or through databases such as Cassandra. HBase can be used as a backend for Lucene. Hive can act as a backend to Lucene, also. Lucene's indexes are used for Solar. HBase can be used to feed Marmot's backend database, through Scoop. Again, Scoop can be used to synchronize the HBase contents to PostgreSQL, H2 or MySQL. Here, Scoop is used to query HBase, but it could be used to aggregate other databases and data sources such as flat files. PostgreSQL, MySQL and H2 are all supported back-end databases to Sesame, although Marmot does not recommend the use of H2 for deployments other than prototypes. Sesame is front-ended by Marmot. Chirp, Solar and Marmot are web applications that can be containerized under Tomcat or Tomy. The web application server makes available all these applications through the HTTP server. The web server handles browser requests. You can have access to your business data from your smartphone, if set as such. Camel allows integration from different contents and sources through message queues and ActiveMQ. Camel allows the integration of these sources into your own web application. Let's now turn our attention to the administration aspect of the ecosystem. Let's start at the bottom of the page, with focus on Zookeeper and Avro, which can get inputs from Storm and Kafka. Zookeeper helps maintain Marmoset, Accumulo and Avro configurations. It provides a simple interface to expose naming, configuration management, host synchronization and such, as well as consensus and leader management. Here, Avro typecasts inputs from Storm or raw data from sensors into contents that is fed to Scoop, Hive or Pig, for further dedicated processing. A web interface allows the management of Falcon. Apache Falcon helps coordinate your data pipeline, life cycle and motion and reduces the overhead of managing your Hadoop data platform. Flume has a convenient web interface. Flume stores logs captured through a web application into your Hadoop platform for analysis. A web interface allows the management of Chukwa. Chukwa is also great at displaying and analyzing results. Chukwa is used to monitor your Hadoop cluster. Knox stands between your web application server and your data. Finally, Hive and HBase are front-ended by Knox, providing security of your contents. Acknowledgements. There are other Apache projects that could have been included in this high-level architecture. The selected projects were included on the basis of their significance to perform a closed-loop process of data acquisition and making it actionable. Trademarks and copyrights are properties of their respective owners.